Let me take you up into the air, up above the clouds, above the weather, above all the aircraft. This is the stratosphere, a place yet to be conquered by humankind. Up here, the air is thin and calm, and it is here that you'll find the Zephyr. This is a strange beast, and the fact that it flies this high is the least strange thing about it. See, it only travels at 40 miles an hour. It only weighs 75 kilograms. It's launched by hand. It's completely solar powered, and in theory, it may be able to stay up here for months. I was last at Zephyr's base in Farnborough in the UK in 2018 when it had just stayed aloft for very nearly 26 days. Since then, it's done 64. So this is how it works. During the day, the sun hits the solar panels which charge the batteries and power the propellers, and the plane climbs to 75,000 feet. When the sun goes down, the batteries completely take over. The propellers do slow down and the plane does lose altitude. The trick though is to make sure you're still above 60,000 feet by the time the sun comes up the next morning and the process can start again. So will the entire wing be covered with solar cells? Every single square centimetre as much as you can is solar?
Actually, the solar array that we use now typically is so efficient that we don't tend to need to do complete coverage.
Really?
Yeah, we can actually recharge the batteries most normal days by lunchtime.
Wow. In theory, is it possible to stay up forever in this?
Well, I think eventually we'll get as close as we can to that. At the moment, our limitation is the number of cycles the batteries can cope with. So a cycle is a day, so a full charge and then a full discharge, that's one cycle. And we're targeting 6 months in the stratosphere at a time. And that's in line with the battery performance that we see coming through.
Everything about Zephyr has been fine-tuned. Every gram counts, every unit of battery density. The precise curve of those wings. So look, I get it. I get that this plane can stay up in the air almost indefinitely. You only have to look at it to understand that it's something pretty special. The main question I have is why? Why would you want this kind of craft? Who would want this kind of craft? In the 20 years since the idea was first conceived, it's almost like this has been a solution looking for a problem. Would it carry cameras? Could it be military, reconnaissance? Since Airbus spun off the new startup company Alto in 2023, it's now being pitched for Earth observation and as a flying base station for mobile phones.
From the stratosphere at 60 or 70,000 feet, we can talk directly to a standard mobile phone. So the aircraft will function exactly like the cell tower that you have today, but it's high up. And because it's so much higher up than the regular cell tower, it can cover the equivalent of about 200 base stations on the ground. So, of course, that replaces not just the equipment on the tower, but it replaces the whole tower. That's the steel, that's the backhaul, the fiber, the microwave, but very importantly, the power, the electricity or the diesel that runs the tower. And in many cases in remote and rural areas, that's the most expensive part of running a terrestrial tower.
An uplink antenna would connect the mobile network to Zephyr, and then Zephyr could serve an area of 7,500 square kilometres. In theory, for months at a time. This is a real proposition. Or, in the event of, say, a natural disaster, a plane could be flown to an area that's suddenly become cut off from the grid.
Mobile operators have something called cell on wheels, COW, which is usually a truck that has some equipment. We have a cell on wings, a flying cow, which is flying cell on wings.
These cows, planes, will fly autonomously. There are no joysticks involved. The pilots send the plane's coordinates and flight plans, but they're mainly interested in how much energy it's using and making adjustments to keep its batteries fully charged. So this is the ground, and this is 80,000 feet. And all this colourful stuff, that's wind. You don't want to be in that. But if you can keep the Zephyr above it from about 60,000 feet and up, it's pretty plain sailing. The problem is, you've got to get to 60,000 feet in the first place, something that can take 10 hours from that weird hand-launched takeoff.
Trying to get it up into the air is probably the trickiest point. There's a lot more weather down on the surface than there is up in the stratosphere, so just trying to get the right conditions to get through that weather is probably the hardest part.
We've spent a lot of time and effort studying meteorology in the tropopause so that we can understand how to transit through it as safely as possible with this aircraft. And we've now done a global study of where all the weather is and all the different weather conditions around the world. And we found some of the best locations in the world to start launching and landing these from regularly.
So where the air is nice and clear all the way up?
All the way through, yeah. And once we're in the stratosphere, we're away.
In fact, Zephyr's parent company has just announced Kenya as the location of its first planned permanent launch site. But we have seen these kind of ventures before. For example, Google's Loon project was also based in Kenya, and its balloon-based mobile cell tower project failed to stay afloat. And what about satellites? These days, very small CubeSats can be put into orbit at much lower cost than their bigger siblings, and they stay up automatically. No power involved. Although, unlike Zephyr, you can't bring them down and swap out their payloads.
With satellite, if you want to talk to a handset, it's very difficult. And if you manage with low Earth orbit satellites, you can talk to a handset, but it would be very limited. You know, it's SMS, maybe a few kilobits per second. You cannot do full 5G. You're not mimicking what a terrestrial station does. And if you have satellites that are really big enough that can do something like this, the economics are so expensive. And then you're spreading them across the whole planet. You're not getting the efficiencies. You cannot scale. So that's on the connectivity side. On the Earth observation side, satellites are great because they can view anywhere on the planet, but not persistently, because they take an image, come back after a period of time. With high altitude platform stations, you can do that persistently, so you can see the change over time.
And there is competition in the stratosphere itself. Similar aircraft are being developed by several companies, including this one by BAE Systems. Whatever the final use for these so-called high-altitude platform stations, HAPS, there does seem to be both the appetite and now the technology to fly high and stay high.